ain't quitters.
Excellent. Okay, so at this point, you learned how to balance equations. You know how to take equations apart. You know how to identify equations. You know what the mole is, right? What is a mole anyway? I'm not talking about the little thing on my face.
Avogadro's number.
What was that?
Avogadro's number.
And what's that, Ryan?
6.022 times 10 to the 23rd.
Okay, so I could have a mole of what?
A mole of oxygen. Anything.
Hey, what do you want to know, Ro? You're raising your hand. You there, Ro? Did you mean to raise your hand?
No, this is who I'm dealing with this morning. So he's
Oh,
doing
his
stuff.
is so cute.
Oh, sorry about that.
Cute.
Okay. Okay, so now we know what a mole is. We know that it's quantity, right? And that's what Ryan was telling us, right, Ryan?
Yes.
It's quantity, it's not mass. We're never going to make that mistake, right?
Correct.
Okay, so since it's quantity, right, we could sit there and use relationships, right? So like in a chemical equation, it's also quantity. So here we have 4 molecules of ammonia plus 5 molecules of oxygen is going to make 4 molecules of nitrogen monoxide and 6 molecules of water, right? Because we've done the balancing of our equation. We know that this equation is perfect, it's perfectly balanced. We've done all of the hard work, and so we can make relationships, right? So I could sit there and use this if I want to scale up or scale down. What happens if I have only 1 mole of oxygen gas? How many moles of ammonia will I need? What happens if I have 100 moles of oxygen gas? How many moles of ammonia will I need? What happens if I have 5 oxygen molecules? How many moles of ammonia will I need? Who's going to answer the last one? If I have 5 oxygen molecules, just 5 of them, like the 5 rings. Jocelyn, how many ammonia will I need to react with that based upon this equation?
Not really sure.
Take a look at it. Look at the equation.
Mhm.
Where's oxygen gas? Show me oxygen gas. Circle it for me.
Right here.
Okay. How many molecules of oxygen gas is there?
5.
5. Okay. So if I want my reaction to work, how many molecules of ammonia will I need? Circle
4?
ammonia in red.
Okay. So,
Okay.
would it be 4 then?
It'll be 4. Pretty simple, right?
Yeah.
Oh, you guys are shaking your boots. You're like, what the hell is he talking about, right? So the chemical equation lets us know what is going to be needed. It's like a recipe, right? You guys make box cakes, right?
Yeah.
How many box cakes do you need to make 1 box cake?
1.
How many eggs?
2, I think.
I think it's 3, but we'll just go with your 2 just to be simple. Okay, because I last time I made a box cake, it's been a while. I think I was 13. So we'll say 2. Okay. How many glasses of milk do you need?
Oh, it's 3. I
It's
just
3?
looked. It's 3.
Okay.
Yeah.
Okay, Siri's here. She's just letting you know she's in class. Okay. So it's 3, right? So in that case, so we have 1 box cake, 3 eggs, and then how much milk or water or whatever liquid you use? Because I know it's not just eggs and.
Hold on, let me go get it again. Hold on.
Are you gonna go get your box cake?
Yeah. 1 cup of water.
1 cup of water. Okay, so we have 1 cup of water, 3 eggs, and 1 box cake,
And half a cup of oil.
and half a cup of oil. Okay, so that's gonna be our recipe, right?
Yeah.
So are you gonna put 8 cups of water in there?
No.
No,
Why?
because it's not what the instructions say.
It's not what the instructions say. So your balanced equation is just like your instructions, right? So these are your instructions. So for every 4 ammonia molecules, I'm going to need 5 oxygen molecules for this reaction to work. Do you guys get it?
Yeah.
Or we're going to need ratios of that. And so that's why we have to use these fractions. So 5 moles of oxygen to 4 moles of ammonia. Or we could flip it around. We could say 4 moles of ammonia to 5 moles of oxygen. So let's say I only have 1 egg for our box cake. And my neighbors hate me, so I don't want to go borrow it from my neighbors. And it's COVID, all the stores are closed. And I really, really want that cake. So everything else I got, but except for the eggs. Can I make that cake?
No.
I can't.
Yes, you can substitute it for 1/4 of a cup of Greek yogurt.
I don't have yogurt. Come on. We're working here. You can't substitute nothing. This is a chemical reaction. You can't just throw something up in there. You don't fuck up my cake.
I'm not.
you're
It's
trying to mess
saying
it up.
substitutions right here. Look, you can substitute it right here. I tried backwards, but
Yogurt. Ugh. No, not in my cake. So
no, there's
what
no
do I do?
substitutions. You can't make it.
I can't make it.
No.
I can't just take 1/3 of what's in the box because it's a 1
Oh.
to 3. Can I take 1/3 of that?
Oh. Yeah, I think so.
Okay. So then what would I do? If my ratio for my cake is 1 box cake plus 3 eggs plus 1 cup of water. Can you guys see my screen?
Yeah.
Plus, oh, you guys wanted to get away from that fraction. 1/2 cup of oil. And that's going to yield a cake. If I put it at the bottom, can you see it if I put it down here?
Yeah.
Yeah.
So if I have 1 egg, I can do it. It's only me. It's not like I'm making it a cake for all of us. You know, it's just me. I'm stingy. Forget you guys. Can I do it?
Yeah.
Yeah. So I would just take what? 1/3. So it'd be for every egg. So I have 1 egg. My ratio is 3. eggs to 1 box. So how much of the box cake am I going to use? That's 1 egg.
A
2/3.
third?
A
Third.
third, right? So a third of a box. Oops. How much water am I going to need? So I have 1 egg. I know it says leg, it's really 1 egg. So what is the ratio between eggs and water?
Third of a cup of water.
It's going to be also a third of a cup. So it's going to be 1 cup to 3 eggs. My eggs are going to cancel out. And then I'm just going to be left with 1/3 of a cup of water. And how much oil? If I have 1 egg, what is the ratio between eggs and oil?
Half a cup.
Half a cup. So we'll put a half up here. Three at the bottom. So it's what, 1/6? Cup of oil. Because eggs are going to cancel out. Yay, nay, may.
Yeah.
Okay. So by having my chemical equation, my beautiful chemical equation about my box cake, I could sit there and still make a cake, even if I don't have enough of everything, right? If I only had 1 egg, I could still make a cake. I've done that. And I set up a chemical equation to do it just to be sure it was right. But I use butter, I don't use oil, and I double it, so because I like it buttery. Okay, you guys got me?
Yeah.
Are you there?
Yes.
Okay, so you guys all know how to cook, right? It doesn't seem too hard. So if your mom, your mom makes mole, anybody makes mole?
Yeah, my mom.
That was Selena. Selena, your mom makes mole?
Yeah, sometimes.
So when am I gonna get invited over to have mole?
I'm not sure.
You're not sure?
You're
Are you gonna
welcome
make
to
it?
over and eat my mole. I hate mole.
Do you have the recipe? I love mole. The chocolate mole? Oh, it's so delicious with that spice. Oh, so delicious. Anyway, going on a tangent. So do you have the recipe for mole?
The recipe?
Mm-hmm.
Wash your hands.
Some
I didn't
of
hear
them
anything from mine.
had a lot of ingredients on them.
But you don't know the ratio, right?
No.
So
I
you got to
think
get the chemical equation for it, right? Pretty simple.
Yeah, my mom just eyeballs it.
She just eyeballs it. Tell her she can't do that because it's hard to tell anybody else, right? She needs to write down the chemical formula. That's the only way it's going to work. Chemical equation, right? Just like we did for our cake here. It's real simple, right?
Yeah.
Yeah. So it gives us a nice organized means of sitting there to repeat the experiment, to do everything over again. Once you have the balanced equation, it's real simple. You can scale up, you can scale down, you can do what you need to do, right? Can you guys see that? Do you see it? Are you with me?
Yeah.
Yeah?
Yes.
Good. Excellent. Glad we're all on the same page. And you see why it's important to understand the equivalencies, right? Why you have to go through and learn all of those equivalencies so you guys can make cake. You guys get that?
Yes.
Okay. I already know what I'm going to put in the fall lab packet. I'm going to have everybody bake a cake. They're going to make, not a full cake. It has to be cut down the ingredients. Because you appreciate it that much when you do it, right? Okay, you guys ready?
Yes.
So do I need to go through each of the different components here? So I need that the equivalencies can be moved back and forth because you guys already know that, right? But you get to see how we can use the chemical equation. That is the important part. Okay, so let's see if we can do a real problem. You ready? Come on, let's go. I know you want it.
I'm ready.
You're ready. All right, let's go. Come on.
Let's do this. Dr. Henry, you know I dreamt about chemical equations last night, which caused me to wake up at 5 o'clock in the morning. I've been up since.
Oh, I'm
not
so proud.
I'm not joking. I was like, out of all the things I could have dreamt of, I dreamt of chemical equations.
See, because you were feeling it. You wanted it. You wanted today to happen. You're like, yes, it's here.
Much.
We're finally here. We're on that breaking point. We're climbing up that hill. You're like, I am here. Okay, so that's good. We'll see. I'm sure I made somebody else dream too, you know. People were having fantasies about chemistry. Oh, I love it.
Israel said you used to his chemistry dreams eventually.
You used to have chemistry. Israel said, oh.
Yeah.
He says you get used to them.
Yeah.
Are you still having the dreams, Israel? Yeah. Okay, here's our first problem. So we want to use that equation that we just saw. So what I'd like you guys to do is write down the equation, but I want you to go through all the procedures. I want you to balance it out yourself. Because what were we working with? We had ammonia, we had oxygen, and it's going to yield what?
Water?
Water and
CO2.
CO2? That's incredible if it yields CO2. Because I don't see any carbon in there.
Ammonia.
So, well, ammonia is one of our reactants. So let's write that down. Plus oxygen. It's going to yield. We have water. And nitrogen monoxide. Okay. So what's the first thing that we're going to do?
Balance this equation, see if it's balanced.
Okay. Show me those skills. I'm here to look pretty.
Would list out what's given to you from the reactants and product side?
Okay, but first thing, okay, so you're saying put out my elements, is that what you're saying?
Yeah.
Okay. So Niho. Okay. So how many nitrogens?
One.
One.
How many hydrogens?
3.
3.
How many oxygens?
2.
How many nitrogens
One.
on the product side? Hydrogens
2.
and oxygens.
2.
Okay. Is it balanced?
No.
Okay, so what do we need to do? What do we need to do to balance it?
Three on the 2 on the H.
Put a 3. You said a 2
No,
here.
Or 2 there, the 2 on the end. 2 by the
2O
NH.
Okay.
Yeah. And
So then
the
that
3
gives me
by the
that's
6.
2 and 6.
The 3 by the H2O.
3 by the H.
Yeah.
Okay, so then that's
6.
Oh no.
6
That's it. It's
and
six.
4.
4 we get trouble now. You get 4.
You want to
No,
throw
we shouldn't do
2
that first. No, 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 no.
front
Is
of
the
it.
end balanced?
No, no, not at all.
No, not at all. What do I need to do to balance the end?
Put the 2 by
Put a
end.
2.
Yeah. Put a 2 there. We get N. But
that's
now
5.
we get 5 now. And then
That's
we
true.
get 2. We get even here. Now we get 5 here, right?
Okay, what did you guys learn yesterday?
Fraction.
Fraction. So what am I going to put in front of the oxygen?
The 5/2.
5/2.
5 and a half.
Ooh, wow, you guys are learning.
It's because I dreamt about this. That's why.
That's why I don't have to put in a computer.
I had an extra study session.
They don't have 5 having computer, doctor.
You don't have what?
5.5 on the computer.
5 having computer. How can I put there?
You put 5
Like I
slash
think-
2.
No, it won't happen. It don't.
So then I multiply the whole equation. So because I
By
can't have
2.
a half of a molecule, right?
Yeah.
As Andy was insisting, you can't have a half a molecule. No, I know, Andy. So what we do? We multiply by 2 to get rid of the half. So we have
Yeah, I got it.
Or
Yep.
NH3.
We're going to have 4 NH3.
We have 4.
Gas. Plus
502.
10.
no, would it be 5? 2 times
Wait.
5 halves.
Oh, yeah, okay. Yeah.
And then O2. Six. 4.
I'm going to move this out of the way. Oops. Okay, piece of cake.
Somewhat.
Okay, those one. But the only thing harder for me is the reading. You know, like NH3, you know, 3 to
Oh,
put
yeah.
together.
Me too. I have trouble with that too.
Yeah, those one. Those numbers okay for me now.
Numbers are okay for you now?
Yeah.
Okay, so now we have a balanced equation, right? So now that we have a balanced equation, we can go to our equation and figure out what's given to us. So what's given to us? And what do we want?
H2O. How many H2O?
It move it. It did. I didn't mean to draw that line. It just happened on its own. Okay, so what do we need to do next? What's given?
The quantity of each.
Do we have to do the quantity of each? What does it ask? What's asking? What's given to us in the equation? I mean, in the question.
So how many mole of H2O?
Yeah, we want to figure out how many moles of H2O we have, right?
So we have to use that 6.22 thingy.
But what's given to us? Wait,
Is
I didn't say molecules. We said
3.20
moles.
oh, okay. Never mind that.
So
ammonia.
what was that, Kayla?
There's 3.20 moles of ammonia.
So there's 3.20 moles of ammonia. So that's what we're starting off with. So that's our starting.
I'm sleeping.
Kind of like we had with the eggs, right? I started off with 1 egg.
Yeah.
3.2 mole NH4.
Okay, what do we want? Was that what we wanted again, Andy?
Moles of water.
Forgot about water. 6H2O.
So we want moles of water.
So put 6 moles of H2O on top,
We're 6 moles of H2O on top.
and then 4 moles of ammonia at the bottom.
NH3. NH3, you cancel out. And then you can see divide by 2.3. 3.2.
That gets you 4.8
What did
moles
you get?
of H2O.
How many sig figs?
Two.
Are you sure?
3.
3.
3.
Because 1, 2, 3. Remember
Mm-hmm.
that 0 counts. Piece of cake?
Can I take a picture of this, please?
Yes, you may.
Take a picture of
Look,
it.
a minute.
Do you want me to smile too?
Did you divide by it? Oh, man. How do you do that?
How did I do what?
3.2.
How do I look so good? Is that what you're asking me?
3.2 times 4.
Yeah, you multiply 3.2 times 6 and divide it by 4. Put in your
Oh.
calculator.
So time first and divide after. Okay.
Yeah. I always multiply across. I multiply everything up top first, and then I divide by the stuff at the bottom. So I just go division. If it's 4, and then if there's a couple of them, I just go, 3.2 times 6 times blah, 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 times blah, 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 times blah, blah, blah. And then I just do each division on its own. But then that way, it keeps me from making too many mistakes.
Okay. Because I don't know exactly. Sometimes they do divide by car. Sometimes I don't know. Okay. That's long answer.
Just,
Hey, Dr. Henry,
Yes, sir.
bear with me here, but are we using the 6 and the 4 because that's on our product side?
We're using the 6 and the 4 because that's what the chemical equation says. We have a 4 ammonia, right? 4 ammonia, and we have 6 waters. So it's 4 ammonia, 6 waters. You see
Okay.
that?
Yeah. Okay.
Okay. So you have to pay attention what's given to you and what you want. Okay? Because really we could care less about the oxygen long as we have enough to sit there and do it. The only time we start caring about it is if we don't have enough, right? If we have excess oxygen, we're like, fuck it. Long as we got enough ammonia, we can do whatever we want to do, right? Excuse my language. It's too early to be cussing. Do you have a question, Ro?
Yeah, Dr. Henry, when I did my calculation, I got 4.8. I don't know where the 0 is coming from.
You don't know where you got the 0?
No.
How many significant figures do we have here?
Oh, 3.
3. So how many do we have to have at the end?
3.
Okay? So that's where we got the 0.
Oh, so you have 3 and I got 3.
So
Okay.
Yes.
if the answer I got was 4.8, because it's 3 sig figs, so I had to add 0.
That is correct. You have to add 0. Yep.
Oh, all right. Thank you.
Yeah.
Man, that's easy to make a mistake on this question like that.
Yeah, sig figs. I
It
always
is.
get you. Man, I collect points. I should start charging you bills for every sig fig you get wrong because I would be a millionaire right now.
Go ahead.
Go
Go
ahead.
half.
You're not in the class. You can get me.
You want to go half? We could go half on it. Is that what you're saying?
No, we're not in the class, so you can like get me.
You can't catch up.
Okay. Okay, you guys ready to move on? Simple, piece of cake?
Yeah, it's just an easy one. You're gonna give us the hard one later. I know that.
Of course, you know how that works. I got to give you a little bit of taste,
Oh, you gotta erase all that stuff.
Oops. Okay. So I need to fix my slide. I just saw that. So basically, this is called stoichiometry. This process of using mole-to-mole comparisons to try to figure out what you have. Like, long as you know your chemical equation and you know how much you're starting off with, you can figure out how much you're going to produce. Doesn't that make sense?
Yep.
Yeah. Okay.
Yes, yes.
And then if you know how much you produced, you can also figure out how much you have, right? How much you started out with, right?
Right.
Okay. Simple. Okay. So the key is that you have to use your gateway, the moles. Moles allows us to get to that point. Okay. And so that's what we're going to start making sure that you guys know how to do, right? So you guys ready to do one on your own? You don't need Dr. Henry to hold your hand?
You're gonna give us another example before we do one on our own, or not?
No, you got it. We're trying
Just
to
the
push
one
you in
and
water.
done?
It's time to see if you guys can swim. You got the fundamentals.
You put me in shark-infested water, though.
No, not yet. I'm working on it, though.
Okay.
Okay. So you guys remember this question? We talked about ethane burning yesterday, right?
Yeah.
Boom. Get started. Okay,
Okay,
I'll let you guys discuss it with each other. Take a picture, and then I'm going to send you to your rooms. You got 10 minutes, only 10.
Dang.
You ready?
Hold on, let me. I gotta
I
take
don't
a
know.
picture.
Hold on.
I'm gonna take a picture first. So.
Take a picture.
Yeah. How many more watching? I forgot everything now. I
Did you
remember.
say you forgot everything now?
How many are on right now? You might as well just throw us in one big old group.
No, I'm not going to throw you in one big old group.
Okay.
Do
I
we
tried.
have this
Hey, I
equal-
tried, guys. I tried.
Good
I think that's a
try.
good idea.
To throw you guys in one big old group?
Yeah.
No, that is not a good idea. It's horrible.
It's horrible. It's horrible.
Okay, are you guys ready? So we're going to give you guys groups of about 4-ish 5s. Let's see those skills. Rooms are going to be created. Let me make my option. Rooms are open. Where do we start?
All part.
All parts?
Yeah.
Oh no, this is easy. Piece of cake, piece of cake. Strawberry cake. Come on, let's go. Where are we gonna start? Who's gonna start me off?
We have to write out the equation.
Okay, so let's start with the equation.
All right.
I'm not putting it down there. You guys are supposed to tell me what's going on.
Okay,
Reach.
C2.
C2,
So it's
H6
H6,
gas
okay, gas,
plus O2 gas product CO2 plus water. CO2, AQ, then water, liquid.
no, CO2 should be a gas.
Gas, sorry.
Gas.
Gas.
Yeah, water can be a liquid, or it could also be a gas sometimes. But we'll put a liquid.
Okay.
Okay,
you gotta balance it.
is it balanced?
No.
Mm.
I was
Okay.
totally off.
So what are we gonna do?
List out a element.
Okay. Show.
Yeah. We have 2 carbons on the reactant side.
Okay.
We have 6 hydrogen and 2 oxygen. Product, we have 1 carbon,
Okay.
3 oxygen,
Are you sure you want a
and
carbon?
2 hydrogen. So
Okay. Is it balanced?
no.
Okay. So what do I need to do to balance it?
From what we did, we put 3 in front of H2O and put 2 in front of carbon dioxide.
You're just way too fast now.
And then
2,
7/2 in front of the
6.
oxygen gas.
You put 13/2?
7/2.
7/2.
Yeah.
Oh, okay.
And now we'll have to multiply the whole equation by 2.
Okay.
And then 7.
So we get
So we have 2 hectane C2H6 gas plus
Guys, you know, when you guys say the chemical names, it just gets me all bubbly inside.
7 O2 gas
Oh, you actually fast. Okay.
4 carbon dioxide gas plus 6 H2O liquid.
Okay. Piece of cake.
And we were given 2.4 moles of ethane.
And last night I tried to put a 7 and 2 on my answer. I cannot find to put. I don't know.
Okay, of ethane.
And we want oxygen,
And we want oxygen.
moles of oxygen.
Okay, so we'll put equals moles of oxygen.
Yeah.
Okay,
Yeah.
so what do we need to do?
We have 2.4 moles of ethane.
Okay.
And we have 7 moles of oxygen.
So 7 moles of oxygen on top.
Yeah.
And then who's on bottom?
2 moles of ethane.
Oh, sorry.
It smells like coffee.
You smell my coffee? That is good. You have a really good nose. If you can smell my coffee from over there.
So moles of ethane cancels out with moles of ethane.
Okay. Okay.
So we do our multiplication and division. 2.40 times 7 over 2. So we got 8.4. Because it's 3 sig feet, we had 8.40 moles of oxygen.
That is correct.
Good job, Aaron.
Thank you.
Yeah, good
You did
job.
it all by yourself, girl.
I know.
Dang, that's a standing ovation right there.
No, I'm blushing.
Turn the camera off. It's okay.
She can teach the whole lecture now.
Yeah. I like that. Good job. So, questions, concerns?
Yeah, can I take a picture of this, please?
Yes, you can.
Hold on. The camera.
Who's going to photobomb him?
We were talking about cake and the ingredients and stuff. So go,
You do speak says 5.
go put it back, please.
I keep forgetting that. You're right, Andy.
Yeah, it's perfect.
And later on, I just
Okay.
go back.
Okay. Oops, I got carried away. Okay, so now that's pretty simple. If we're going from moles to moles, right, there's nothing too complicated. But what happens if we're given a mass? What are we going to want to do?
Is it the DMV or no?
DMB? No, DMB would be, that's giving you density, right?
Okay. So is it just mass over mole over mass?
What is that called? Moles over mass or mass over moles?
Grams per mole?
No, I dreamt about it. I should know.
Moles of a mass.
Mass over moles.
Grams per mole?
Grams per mole. Those are the units, but what is it called?
Is it called a? Oh my!
Molar mass?
Molar mass. That is
Oh
correct.
my God! Why didn't I?
That is correct. So we're going to have to use the molar mass, right?
Bro, I was literally thinking like, isn't there a word with both of those words? I'm an idiot.
So if we're given mass, we're going to have to use the molar mass to change it to moles. Make sense? And then, so you always want to think of it, moles is your gateway drug, right? So you always want to get into moles, okay? Are you guys ready?
Yes.
Yeah. Okay, so the beauty is if we're given a mass of 1, we want to change it to moles by using the molar mass. Then we use the stoichiometric, you know, basically the molar-mole ratio, stoichiometric ratio. And then you want to use the molar mass of what you want to sit there and change it back into mass. Okay, pretty simple, not too hard. Excellent. Okay, this is basically just telling you everything that we just showed you in that diagram, step by step. This is a table saying that, hey, guess what? We can do this, right? And this is the schematic of how you go about it. Here's the problem. You guys ready?
Mm-hmm.
We'll do the first one together, and then the next one you guys have to do on your own. Okay, the question says, how many milligrams of nickel 2 chloride in a solution? Okay, how many milligrams of nickel 2 chloride in a solution if 503 milligrams of silver chloride is precipitated in the reaction of silver nitrate and nickel 2 chloride? So, didn't I tell you guys that nomenclature, bread and butter?
Mhm.
Without it, you can't get started.
Mhm.
Okay, let's go. Let's do some naming. We got to get this chemical equation written.
Well, okay, so
Who are my reactants? We're going to underline those in red.
silver nitrate and nickel.
Silver nitrate and
Yes.
Nickel chloride.
nickel chloride. Okay, who's going to be the products? We're going to circle those guys in green.
Is it nickel chloride? Nickel and chloride will be the product?
Well, how can nickel chloride be a reactant and a product?
Silver chloride.
Silver chloride.
Silver chloride.
Yeah.
Sorry about that.
And whoever's left over after that, right? Which we'll figure out here in a second.
Right.
Okay, so let's write our equation. Okay, give me my reactants.
So silver nitrate is AgNO3.
Okay,
AG.
you mean AQ?
Oh, AQ, yeah.
I always say AG.
I know, and I always correct you. One day we're gonna get this right, right? Okay,
And then nickel is, I don't know, Ni, I think.
Ni, okay.
Nice.
Cl.
Two.
2.
Aqueous again.
Okay, and what are we producing?
Silver chloride.
And 1 to 2 to the 1. So ACL. Yeah.
Okay,
AQ.
2.
AQ, are you sure?
No, AQ2. CI2.
Are you sure?
Is that a solid?
Yeah.
It's
It's a
precipitate.
solid and it's just AgCl.
And then I put an S, right? For solid.
A solid is not liquid.
It's solid, it's a precipitate. It's precipitated.
CL in the blue though. CL in the green is non-metal. Okay, solid then.
Look at silver. Look at silver and chlorine together. Or chloride.
Oh, AG.
Remember this paper?
Oh, okay.
Uh-huh.
Okay.
Okay.
Oh, because all I have is one. Oh, no.
If you look on the other slide, it has the other one. Okay. So, what is the other product? How can I figure it out? So we said AgCl, they got together. And
1 and 2 to 1.
so who's the other guy?
Is Ni.
Ni.
Nitrogen. Yeah.
Okay. Not nitrogen. You mean nickel, Ni.
Yeah.
And then
Nickel.
And then you
NO.
said
Tree.
NO3, which is nitrate.
Yeah.
How many NO3s am I going to need? Just 1, 2, 3, 4, 5, 17.
No, too much. Let me see. And
Two?
it's small.
I think it's 2, isn't it?
That is
I'm
correct.
reading it.
Is it aqueous? Solid, liquid,
Yeah.
gas?
Aqueous.
And I.
Is it balanced?
Yeah.
And I here. And I.
No?
I think it is.
You think it is? I see. Let's do the math.
Not balanced.
Okay.
No, it's not balanced.
How many chlorines do we have?
2. And then there's 1 right there. Yeah, never mind. I'm tripping.
How you know too?
How do I know 2? I look on the equation.
And it has 2 chlorines right there.
Okay.
And then
How
the
many
one on
silver?
the right- 1.
So let's see. 1
How many nickel?
nickel.
1.
1 and
1.
1
And how many nitrates?
Ng and O.
6 on the product and 3 on
I have 6 nitrates.
Oh,
on your product.
On the product 6.
Yeah, you have
I have
6.
6 nitrates.
No.
Not 6.
Yeah.
I have 6.
Oh,
nitrates.
2. You have 2.
Oh, sorry.
2. Yeah, I'm tripping. I always do that.
And then how
And
many
then you
nitrates
have-
do I have over
You
here?
have 1 on your.
Yeah.
Yeah, I'm
See,
such
I'm
an
just keeping
idiot,
them
bro. I
together.
always do that.
Okay, is that balanced?
No.
No. Okay, so what do I need to do to balance it?
Add a 2 coefficient in front of AgNO3.
Okay, so that means I have now, that's 2. This guy is 2. So the nitrates are balanced.
And then add, on your product side, add a 2 coefficient in front of AgCl.
So then that means we have everything balanced now?
Yes.
Okay, we're good to go. Now we're ready to start.
and doctor, I have one more question for you.
I may have one more answer for you.
Just one. You know the NO is nitrogen. You don't put N in an O. You put it
can.
together.
Yeah, you can put them separate. But you can
Separate
also-
out. Can I do that?
Yeah, but you can also put them together because they stay together, right? They never separate. You see that?
Oh.
So I can keep them together to make it easier for myself. So
Oh,
yeah,
okay.
I could have done it either way.
Okay.
Okay. Good question, Andy.
Because I do that all night to do homework like that.
Yeah, no, you can do it either way. It's fine. It's not wrong. Like I told you guys in the beginning, there's about 150 different ways of coming to the same answer. Right? If you show me your way, then it makes it, I can see if you're on the right track. But if you don't show me your way, I can't, So just show me your way. And I'll say, oh yeah, he did it the longer way than I do it. So it's okay.
Oh, I do the shortcut next time.
Okay. Well, I prefer if the longer way gets you the right answer, that's what you want, right? You don't have to take the shortcut. Because sometimes when you take the shortcut, you get lost, right?
Okay.
Are you ready? What are we
Ready.
doing next?
Uh,
So I'm just going to erase this. Can I erase this? Or do you guys want to see it? You want me to just move it somewhere
erase.
else?
no, we don't need to see it. We just say,
You don't need any more?
no, I don't need it.
Okay, good. Okay, since Andy was the only one talking, I'll listen to what Andy said. Okay, Andy. Okay, what's next? Where do we start?
Are given.
Our given. Who's our given?
Right.
We're gonna underline our given in our equation.
503 milligrams of silver chloride.
Okay. So we have 503 milligrams of silver chloride.
Yeah. 500. Silver chloride, silver HEI, Cl. HECl.
AgCl. Okay, I got you. So then what do I do?
So your lines, your little cross.
My cross.
Yeah.
On the bottom right, you'll have 2 AgCl.
You have
I
to
think-
convert.
To HECl.
Ah, what was that? What did you say?
You have to convert
Oh.
nickel chloride.
I'm gonna have to convert to nickel chloride.
You have to convert nickel chloride to milligrams.
I have to convert nickel chloride to milligrams. So we have milligrams. Is milligrams mass, moles, or is it mass or quantity?
Mass.
Quantity.
Mass.
Mass. So can I just compare them straight to each other?
No.
No. So what do I need to do? What's the gateway drug?
Moles.
Moles. So we need to change it to moles. So how can I change 503 milligrams of silver chloride into moles of silver chloride?
You put 1 mole equal something.
So
1 mole on a. Yeah.
So since this is milli, right, in here, can I just say millimole?
Yes.
Yes.
Is that a thing?
Mole.
What was that?
Is that a thing?
Yeah,
Oh, okay.
because it's just factorials of 10, right? And then, so then at the bottom, I'm gonna have milligrams. So how do I calculate the molar mass of chlorine? So I'll just tell you this right now. So grams per mole will equal milligrams per millimole.
Oh, wow.
Will equal kilograms per what?
Kilomole.
Kilomole. Will equal, I think it's, what is it, M, capital M, megagrams
Actually.
Megamole.
per megamole. Okay,
Okay.
okay. So how do I calculate the grams that I need at the bottom? What do I use? I know, I feel exactly the same. I'm gonna have millimole, but millimoles, am I just gonna put a millimole, 2 millimoles? Where's this number coming from? Where is this number coming from? And is it a 2?
It's coming from the silver nitrate, isn't it?
Yeah, what about, is it the silver nitrate?
The nickel.
Because aren't we trying to get rid of milligrams of, we're getting
Silver
rid of
chloride.
milligrams of silver chloride. So where am I going to get this number from?
From here.
From where?
The Roman numeral?
From here. Cheese scale.
What is grams over moles?
Oh, so you're gonna get the
Grab.
6.02.
You said 6.02?
Times 10 to the 23rd. So
Okay.
the atomic mass.
Okay, so I'm going to ask you this, right? 6.02, what units is that?
moles.
Is it
Right.
moles?
One more unit.
1 mole is equal to 6.02 times 10 to the 23rd of what?
Anything.
Okay, anything except,
More.
can it be mass?
No.
No.
Okay, so it could be donuts, it could be roaches, it could be quantities of things, right? Or molecules or atoms or eyebrows, right? But it's not going to be mass, right? Because you don't have a dozen of grams, do you?
No.
So when you talk about a donut, you say you have a dozen of donuts, right? You don't say I have a dozen grams of donuts. Do you?
No.
Okay.
Gotta travel.
So
My mind to go to convert the mg to grams and then do grams per mole and then grams
see, how do
per
you
mole.
calculate grams per mole? Because that's what we have right here, right? We have milligrams. You could change this into grams, but you don't have to because they're going to be equal to each other. They're proportional to each other. So if I can change this to grams per mole, how do I change it to grams per mole? Or where do I find my grams per mole?
The mass in grams per mole.
Where do I get that from? Does it just pop out of my butt? I blow and it comes out? Where do I find that?
The mass of silver and chloride on the table.
Are you saying the atomic mass of silver? And the atomic mass of chloride?
Yes.
Yes, okay, thank you. Yes, that is correct. Be confident, yes. So I go to my where? Where do I find it at?
Your periodic
What
table.
My periodic table, right? So I go to my periodic table. What is the atomic mass of silver?
108.
108.
Okay, 108.
Oh, God.
I said that earlier, but you didn't hear me.
Oh,
No.
I promise to God.
Tell me that.
Right,
Wait, how many
right,
times does he tell me?
right hand to God.
I said
Right hand to
that
God, I said
before.
that. Right
Okay,
hand
we're
to
gonna.
God, I said that.
Okay, so what we're gonna do? I'm gonna rewind it, right? Rewind the recording,
Go ahead.
and then when you don't say it,
I
you're
said
gonna
it
owe
wrong.
me
though.
20 bucks.
No, I said it wrong because I said atomic mass. That's what I said it wrong. That's wrong, right?
No. it's
Yeah,
the
I did hear
mass.
someone say atomic mass.
Thank you.
did
I
hear
said it
someone-
right hand to God. I said it, but everybody talked over me.
Oh, okay.
I promise to God. That's
Oh,
on that's
don't get
on the Holy
sensitive.
Bible.
It's okay. Don't get sensitive. It's okay. We heard you. We all heard you.
See, no one listens to me. Everybody talks over me.
Okay, so we have 108. That's my silver. And you guys see
And
my
then-
corner one right over here?
Yeah,
Yeah.
And then the CL.
is 35.45.
So what is it? One. Oops.
$143.
So 143, it'll be 143.2. Actually, roughly about that. Grams per mole. So I could just put 143.2 milligrams. because these are all equivalent, right? You want to know why they're equivalent?
Yeah. Same.
So how
Shouldn't
many?
it be 2 chlorines?
Nope.
Because you have
silver-
the millimole on top, so it's equal, isn't it? Or milligrams to millimole.
That's right, exactly. So it'll be 1,000 milligrams will equal 1,000 1 gram equals 1,000 milligrams, and 1 mole equals 1,000 millimoles. So you have 1,000 over 1,000, so it just cancel each other out.
Yeah, makes sense.
Okay. So Juan, no, because now we have to do the ratio, right? Because we're looking for the grams of silver chloride. So we got moles. Now we can use the ratio that we have. Do you understand what I'm saying?
Yeah.
Yeah.
Okay. So what is the ratio? Because we want nickel chloride, right? Grams of nickel chloride. That's our goal. So what is the molar ratio? Because I have moles now, right? Because if you do the crossing out, that's going to give me moles. So what am I going to use next? Everybody yell at me at once.
You flip it again.
What was that? I put nickel chloride, so I'm going to have moles of nickel chloride. Millimoles of nickel chloride.
Megamole, 1 megamole.
Millimoles.
Dr. Henry,
Yes.
1 mole equals 1,000 millimoles.
1 mole
Yeah.
equals 1,000 millimoles.
Okay. And I said, do we flip it to convert it to grams?
Do you flip what to convert it to grams?
Flip well, we already crossed out milligrams, so now we have millimoles left over.
Yep.
And then convert millimoles to grams.
But why would you change? Because you just got it from going to milligrams to milligrams. That's mass, right? So why would you go from mass to moles back to mass? Does that make sense? For silver. Because you want, what is the goal? What do we want, David?
Never mind. I'm sorry. I'm wrong. I looked at the directions again.
It's okay. It's okay that you're wrong.
Yeah,
but
I looked at the directions of how many milligrams. So we want milligrams. We don't want to go back to grams. So what I said was wrong. So I caught myself again.
Yeah, but that's okay. But the problem, right? So, but it's milligrams of what, David? That's the important part. It's milligrams of what?
It wants to know how many milligrams of nickel to chloride.
And what are we starting off with?
Milligrams of silver chloride.
That's right. So we're starting off with milligrams of silver chloride. So how do I figure out how many milligrams of nickel chloride am I going to need? What am I going to use? See, you're asking all the right questions there, David, whether you recognize it or not.
Yeah, because I understand the patterns of it. I was going to ask, my next question was, so you find, next is to find the mass of the nickel to chloride now, right? And then
not yet. How do we get from moles of silver chloride? Because we have silver chloride over here, right?
Yeah.
How do I get from moles of silver chloride to moles of nickel chloride? What do I use?
Don't you have to calculate the atomic mass of nickel chloride? with your atomic.
Relax. I'm asking you about moles, right? Because right now, if you look at this, if we do the calculation, we plug this into our calculator, up until this point right here, up until the point right here, right? We have, what are the units that we have? Because we crossed out milligrams. What do we have? What are our units?
Millimoles.
Millimoles of what?
AgCl.
Silver chloride.
Of silver
Silver
chloride.
chloride.
Okay, so I have millimoles of silver chloride. How in the hell am I going to get to millimoles of nickel chloride? You need to cross a bridge, right?
You
That's
have
what
to
you need
cross
to do.
out the silver chloride?
Okay, how do I do it? Do I just cross it out just for the hell of it?
No.
Yeah, that's
So
a
then
good
what has
idea.
to be at the bottom?
Would it be
Silver
the
chloride.
two
Okay, 2
millimoles
millimoles.
of silver chloride?
Okay, and then what should be up top?
After that, it would be the, since
So
we
what
did
is
the
the
math
ratio?
for the,
So you said 2? Where did you get that 2 from? I don't understand. So I
from
have
the
silver chloride.
coefficient? From
That's the
the,
coefficient. So don't I need the coefficient for the nickel? What is the coefficient for the nickel? For the
one?
nickel
One.
chloride? 1.
Oh, okay.
Okay. Okay, so that's good. So now we can cross out our silver chloride, and now we have moles of nickel chloride. Now, David, you were saying, now that we have moles of, or millimoles of nickel chloride, how do I get to milligrams?
The atomic mass? Or
The atomic mass, that is correct. Okay, so what is the atomic mass of nickel chloride?
Nickel is
59.
59 and chloride is
35.
35.
You guys are a little conservative with your rounding up there. So nickel is 50, I mean, not conservative, a little liberal. Liberal elite. So
So
it's
you just want to keep it at 58?
58.6 or 58.7, right?
Okay.
Oh, okay, so 58.7. Sorry.
Okay. And then our chloride, we have 2 of them. And how much is each one? Each one is 35.4.
35.4
times 2.
120.5.
Or we could say 35.5. Want to be
129.5.
maybe 71.
okay, 71. So altogether, you said 129.5 or 120.
129.7.
129.7.
we can't just make that 130?
Okay, so let's make it 130.
Nah, we're too liberal.
Oh, yeah.
You liberal elite.
Better not do the wrong thing, we'll get in trouble.
Okay. So, and it's milligrams per millimole. We're using milligrams. Sorry, just have it. Okay. So that's going to be on top or on bottom? 130? Going to be on top or on bottom?
On the bottom.
Top.
Okay, half you guys say on top, half you guys say on bottom. Who should I
I
listen
say
to?
top.
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 Top. Because we have 130 milligrams on top, and then we have 1 millimole on bottom.
Oh, then it crosses out.
That's right. That's why we do all of that crossing out crap, right? It's not just because it looks pretty.
Bless you.
That's right. See, he gets excited about chemistry.
I know.
You
can be over.
Yeah, I should maybe pay him to take your test. May ace it.
Yes.
He'll definitely get a better grade than I get. So.
Take it.
Hey, what did you guys get?
Oh, I haven't done that. Let's lay down right here for a little bit.
That's a lot.
It's gonna be 503 times.
$22.83.
You got, repeat that?
Is it 22.83? Or just 22.8?
22.8? That seems a little small.
It's 228, no?
228, yes.
0.31.
Yeah. So you're off by a factor of 10. So you must have either divided by, this is a decimal here. You may have divided by 1,432 instead of.
Oh yeah, that's what I did.
Oops. Sorry. There we go. Okay, piece of cake. Questions, concerns, ask, credit. Hey, you guys ready for the next one?
Please, what was our answer for this?
It's 228 milligrams of nickel chloride.
Okay, thank you.
Okay, questions? What was that? What was that, Andy?
No, I got it.
You got it? All right,
Yeah,
that's good. Okay, I can change the page? Or you want to take a picture, Ro?
I already took a picture.
Good, good.
Hold on, let me save it. Let me save it real quick. All right, thank you.
Okay. Come on. Okay. Okay, so are we ready for our next one? Okay, now we're going to talk about yield. Okay, you guys ready for yield?
Yes.
Okay, so when we talk about yield, yield is what we actually produce. So we have what we call our actual yield, and we have what we call our ideal yield. So actual yield is what you actually produce experimentally, right? Ideal yield is what you produce on a piece of paper on your calculations, right? So our last one, we calculated the ideal yield. So if we had done that experiment, and then we would have our actual yield, okay? And then what we typically do is put it in terms of percent yield. And percent yield is going to be your actual over your ideal. Because in theory, your actual in real life is going to be less than your ideal, right? And I'll explain why here in a second, okay? So, but first let me tell you a story. This almost got me, or I almost quit chemistry. I almost quit college, to be honest, because of this. So I was taking analytical chemistry. Analytical chemistry is basically, it really deals with numbers. You're doing calculations all the time. You're trying to analyze material to figure out how much of the product you actually made, and then how much of the reactants that you actually used, and then you do a lot of ideal yield. And so it was my first couple of labs, and I was doing my lab reports and everything like that. And I'd turn them in, but I would notice that I was never getting 100%, right? And I did the experiment, and I did it again, and I was pretty good at, doing the experiments because I'd read in advance, get it all worked out before I went into lab, and so I'd get in there and I'd whip it out real quick and check my answer, and I'm like, oh, I'd be off. So like the first time I did it, it would be like 89%, right? So I get 89% yield. That means that I'm off technically because you should get 100 if it's perfect, right? And I want to be perfect. I want to be on top of the food chain. I hate being on the bottom of the food chain. I always want to be on top. Now, I will do my best to be on top. Sometimes I have to settle for being second, right? But I want to be on top, right? I want to be looking down at everyone else. That's just how I am, okay? So I am competitive by nature, okay? You guys understand that? Can you tell? I know it's hard to tell. I don't seem that way at all, do I?
Nah, I can tell.
Not one bit, right?
No, you're like, I bet money on it. Bet money on it.
So I am like, I should be getting 100%. I did everything that I was supposed to do. I went through, I checked everything off. I had everything organized. I did what I was supposed to do. I should get 100%, right? So, I'm like, okay, it didn't work out. Got 89 the first time. So I said, oh, okay, I'm going to do it again, right? And usually we do 3 trials because you take into consideration errors that are associated with things. And then, your areas are really close. My errors were close to each other. They were all about 89%. So then the next time I did it again, and I got 87%. I'm like, what the fuck, right? So I'm getting upset at this point. I am really upset. That's 13% off. That's not, that 11 before. Now it's 13, So I'm like, okay, try one more time, right? And then, at this point, everybody else is done and everything like that. And I'm like, I'm getting upset. And then, so I do it again. And then I get 88%. I'm like, okay, so I got 88, 89, and 87. Why am I not getting 100, right? So I talked to the TA, right? Because the TA is like, you got to go, I can't be here all day. You got to go, right? And so I'm like, okay, I'll go, but can I come to your later lab because I didn't finish, right? I didn't want to tell him that I was wrong, right? Because I wanted to fix the problem myself. And then, once I fix the problem, then it's okay. So I went back, went through all the experiment again, wrote it all out again, making sure that I didn't do anything wrong. And then I talked to my buddy and I'm like, hey, what did you get for your yield and your percent yield? Oh, I got 100%. And I'm like, okay. So, and I believe, and I'm like, fuck. And then I said, okay, can I see your lab? And he's like, oh, yeah, sure. And I'm like looking at the lab and everything like that. And I'm like, okay. So on the thing, it said 100%. So I just assumed that, yeah, he was doing everything right. And I fucked up, right? So I go back in later that night. I do it again. I get the same percent, 89. And it's funny, almost exactly the same numbers. 3 times I did it again. TA was like, hey, you got to go, right? I said, no, let me finish. He's like, what is taking you so long to finish? And I'm like, hey, I said, let me do it one more time and then I'll explain everything to you. He's like, okay, go ahead and do it. So I go ahead and do it. And I get 89% again. I get so fucking mad. I get my lab notebook. I toss it across the room. I said, I quit. I'm done. I'm finished. I storm out of the lab. I'm really upset, right? I am so pissed. And, my TA waited a minute and he's like, what the hell's going on? Probably to himself. Then he comes on and he's like, Henry, come here. I'm like, what? He's like, what's wrong? He's like, what's wrong with you? He's like, you did this experiment over and over again. He says, usually you're one of the first people to get out of the lab. What is wrong? What's going on? And so I tell him, I said, well, I did this experiment. I said, I did it 7 times. I said, and I got between 87 to 89% every time. Why am I not getting 100%? I did everything I was supposed to do. I said, maybe I'm just not cut out to be a chemist. Maybe I'm not cut out to do this stuff, right? Chemical engineer, right? What am I, and he's like, and he kind of laughs. He starts laughing at me. He says, what are you laughing about? So then I'm getting mad again, right? I'm like, hey, you're laughing at me. Now we're going to fight, right? So he's like, you're never going to get 100%. He said, come with me. So he takes me to the back room, to all of the chemicals in the thing, and he just shows me the bottle. On the bottle, it says ACS, right? Which stands for American Chemical Society standards, essentially. So basically, it's not going to be the cleanest. It's just for teaching, right? So it was 89%. So every time I was getting the percent yield that was there, right? That was in that bottle. Okay. So in theory, I was actually getting what I was supposed to get. So what else is in the bottle that makes it so impure? Or why would you get mistakes? That's what I'm asking.
Like contaminants?
Contaminants. Yeah, often those chemicals have contaminants in it, right? So you may never get 100%. What was that?
Sorry, my son's over here trying to feed a cat.
Oh, okay. I thought he was answering the question. So yeah, we have contaminants in a lot of the chemicals that we work with, right? And so the reason why I would never get 100% is because there were contaminants in it. There was no way I was going to get 100%. And then we also take into factors such as human error, right? Do you guys make mistakes?
Yes.
Yes. I make mistakes all the time, right? So there's always going to be, you're not going to get 100%. Now, if you start getting 115, 120%, that's usually a problem, right? Because that means your actual is more than your ideal, right? That probably means that somebody peed in your solution or something like that, or spit in it, you know, which has happened to me before too. So remember, I'm competitive, so I know I piss a lot of people off, you know, and I talk noise. If you can't tell.
Oh, we can tell, all right.
Mm-hmm.
So the moral of the story is, right, you're not going to be perfect. And so the way that we account for that is by looking at the percent yield, okay? And so sometimes we have to take that in consideration if we're trying to get a certain quantity of solution made or a certain amount that we actually need, okay? So you always want to take that in consideration, and I guarantee you, the most that you're ever going to get in terms of purity, you're going to get some that are going to be like 99.910, but that's going to cost you about $1,000, where the one that cost you 89.5% is going to cost you about 20. So you're really going to go for the cheaper one and just say, okay, I'll just calculate that percent error that I'm going to make and accommodate for it. Okay, you guys ready? Are you there?
Yeah.
Yeah.
Good.
Yeah.
So the moral of the story is you're going to have impurities, right? And you got to sometimes account for those impurities. Okay, so let's figure out how we use percent ideal. So this is our final equation. Percent yield is going to be actual yield over ideal. Okay, so here's the question. A solution containing 3.8 grams of barium chloride is added to a second solution containing excess sodium sulfate. Barium sulfate precipitates. Calculate the ideal yield of barium sulfate. If the actual yield is 3.37 grams, calculate percent yield. Okay, so let's do this. So what are we going to do? First thing, number one.
Giving.
Given? Okay, so let's find our givens. This is a given. 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 Okay, so what is the first thing I'm going to do?
Write the formula. The equation.
Write the equation. That's right. We're going to write our equation. So what is going to be the chemical equation? What are our reactants?
Chloride and sodium sulfate.
Okay, I heard barium chloride and sodium sulfate. Okay, so what is the chemical formula for barium chloride?
BrCl.
You said BI?
It's BA.
BA. BA. Cl, Cl1, Cl2, Cl3, Cl4, Cl17,
And B
CO2?
Cl2 minus.
Cl2.
Oh, I'm sorry. Yeah.
Solid, liquid.
It should be aqueous.
And you said the other chemical was sodium
Sulfate.
sodium sulfate. What does that look like?
Na.
No. Yeah.
Sulfate has a true charge, so you
Na2SO4.
Na2, SO4.
yeah.
Hey, this is chapter 10, right?
This is chapter 10, yes.
Okay. Oh.
And we're gonna make
Sodium chloride.
oh, what is the chemical formula for sodium chloride?
NaCl. 2? What? No, just NaCl.
Okay. Solid, liquid, gas, aqueous, Kool-Aid.
Solid.
Aqueous.
Aqueous.
Aqueous is the answer.
And then barium sulfate precipitates, so it's going to change into a solid.
That is correct.
I remembered something yesterday.
I like that. I like it when you remember something. Oh, what is the chemical formula for barium sulfate? I'm just writing it.
BaSO4.
And you said solid. I just got excited because you told me it was a solid and he. Hey, are you guys good? Is it balanced?
No.
No.
No? How do we balance it?
Put a 2 coefficient in front of the sodium chloride on the product side.
Is it balanced now?
Yes.
Yes, it is balanced. So otherwise we break it down. Write them all down and check both sides, and you'll see that you have 1 barium on both sides. You have 1 sulfate on both sides. You have 2 sodiums on both sides, and you have 2 chlorines on both sides. So balanced. Piece of cake, are we done?
No.
Oh, okay, what do we need to do next?
Find the ideal yield.
Find our ideal yield of
barium sulfate.
Barium sulfate. And we're going to be starting off with
3.8. Yeah, that one.
Start off with 3.18.
okay. What do I need to do next?
You need the molar mass of barium chloride.
Okay. Barium is 137.
137.3.
Okay. And then the chloride, we have 2 of them.
35.
2 times 35.5-ish.
Mm-hmm. Do you want us to have decimals in this one?
You can.
Okay. Uh, 2083.
$71. So you said 2083. Units, grams per mole. Okay, so now what do I do? What do I do with this? Am I just doing it to make myself look pretty?
That would be on the, it'd be 1 mole barium chloride over 208.3 grams barium chloride.
Okay. Okay, what's next?
Would you do it for the
Let's cross some things out. So I might add a little clarity. So what do we have now? What are our units?
moles
Of what?
barium chloride?
And what are we trying to calculate?
The
Barium sulfate.
Barium sulfate.
Okay, so we want barium sulfate. So how do I go from moles of barium chloride to barium sulfate?
You have to find the mass of barium sulfate.
I have to find the mass of barium sulfate. So how is barium, because I have barium chloride. Okay, let's go ahead and find the mass of barium sulfate just for the hell of it.
No. Never mind.
Wouldn't it be moles to moles?
Moles to moles. How do I get to moles to moles? Where do I find that at?
More of the barium sulfate under the over the barium chloride.
You said 1 mole of barium sulfate over 1 mole of. Is that what you're saying?
Can you do moles over moles?
Yeah, I can do moles over moles, but where am I going to get that from? How do I know how many moles of barium sulfate I need for a barium chloride?
From that equation.
From my equation.
Yeah.
Okay. Okay, so what is the molar ratio between the two?
1 to 1.
1 to 1. So that's what we're going to do.
Okay.
Okay, and now you were saying about that molar stuff, that molar mass.
Mm-hmm.
Okay, so how does that work? What is it? I'm calculating the molar mass of barium sulfate, as Kayla was saying earlier. So 137.3 times sulfur, which is
Plus sulfur.
Yeah, sorry, plus sulfur.
37.3.
32.
32.
And then 4 oxygens. 4 times 16. What is that? 464. Is that right?
Yeah.
I think I did it. 233.4. Did anybody get?
233 point. Yeah.
233.4.
Yeah.
grams per mole. Okay. So where am I going to put that? And how?
It'll be 233.4 grams barium sulfate over 1 mole barium sulfate.
Okay. See, he's getting excited. He's like, oh, we're getting to the answer now. Happy.
Yeah.
Okay, what did you guys get?
3.56 grams.
Okay. You got 8.56?
3.56.
You said 3.56. Okay, so that gives me my grams of barium sulfate, and that's going to be my ideal. So how do I calculate the percent yield? Percent yield equals what?
Actual yield over ideal yield times 100.
Okay. Okay, and our actual yield is what?
It's given 3.37 grams. No, wait, you said actual or ideal?
The actual.
Oh yeah, it's given in the problem. Hey, is it always going to be given to us?
Not necessarily. Sometimes you may have to calculate it
Okay,
if they give you the percent yield.
right.
Or sometimes you have to do it experimentally.
Mm.
And what did you guys get?
Wait. I got 95%.
Sig figs?
Oh, sorry, 94.7%. much math.
Okay. Questions, concerns, cash, Venmo, credit, cakes, cookies, candy.
Red Bulls.
Oh yes, I love eggs.
I have pie.
What was that?
I have pie.
You have pie? Pie will work. Especially if it's strawberry.
Mm.
Okay.
Straight up pumpkin.
Pumpkin, yeah, it's okay. Okay, are we ready? Ready? Round two?
Ding ding.
Yeah.
I can move on?
Yeah.
Wow.
Did you say meow?
Who?
I thought I heard somebody say meow.
I heard it.
How to?
Okay, Ro, did you get your picture?
I got my picture.
Yes, sir. I got it. I saved it.
Okay,
Oh,
good, good. So I can clear?
Yes, you're good. Thank you.
Okay, who tapped out? Somebody left us. They're like, it's too much for me. My brain's fried. That's right. Okay. So, this one. I'm going to put you guys in groups.
Oh my God.
So I'm actually going to add an additional 5 minutes on. Instead of giving you the 10 minutes, I'm going to give you 15 minutes. Okay? And that additional 5 minutes so you guys can take a potty break and stretch.
Thank you.
Okay? So you can tell that person who left, get their butt back here. They don't get off that easy. Okay, well, that's all right. We can work together, see
Even
what
then
you
we
guys...
get 1.5. And get 1.5, and then after that we get one more over 85, and then after that we don't have to continue no more. I should put one more, two more. No,
Oh, you're saying I should give you more questions. Is that what you're saying?
no.
Oh.
Yeah, later after this one.
Okay, after this one, huh? Okay,
After
so let's
we
work
gonna
through
have
this. Okay, so what do we need to do? It says solid sodium nitrate decomposes to solid sodium nitrite and oxygen gas upon heating. One set of reaction conditions gives 95% yield. What mass of sodium nitrite will be produced by the decomposition of 1.5 grams of sodium nitrate?
So sodium nitrate. It costs the life first. Sodium nitrate will look for sodium.
Okay, so what is the first thing that we need to do?
Cost the life first. So what?
Cross the life?
Yes.
What do you mean by that?
Which one is we have to write up there?
Oh, so you're saying the equation, right? The equation?
Yeah.
Okay.
Sodium is Na, nitrate NO2.
So you said sodium is Na. Okay.
And then the NO3.
NO3.
Yeah.
And
And
it
then we
says-
go out there.
Solid, liquid, gas, or other?
Air. And we make it become 2.
Wait, hold on. Slow down. Solid, liquid, gas, or other?
Solid.
Solid. No, let me see.
That's right, solid. Because it says solid sodium nitrate.
Solid?
Yep.
Oh, God, you got me, doctor.
Okay, and then what are we making?
Another solid again.
Okay, but what is on the other side?
We put Na.
Sodium nitrate.
Na,
Nitrate again.
nitrate or nitrite? What is the difference between
Nitrite.
nitrate? What is
NO2.
nitrite? NO2. There we go.
Yeah.
Good job, Andy.
and then oxygen 2. Solid. Oxygen is a gas, right? Yeah.
The gas. That's right. Okay. So is it balanced?
No.
No. What do I need to do to balance it?
They do that already. It's 2 Na first, and then 2. Again, there's a balance.
Okay.
Yeah.
Good job. Okay, so we got our
Yeah.
equation. So what do we do next?
And then we just what the mass per they ask like a gram of sodium hydrate. So we
It says, what mass of sodium nitrite will be produced by the decomposition of 1.50 grams of sodium nitrate? So you're saying I should start off with this? Is that what you're telling me?
Yeah.
Okay.
Sodium nitrate.
Yep. Oops, sorry.
So we put gram 2 or put just G?
No, we put G for grams. Yeah.
Oh, okay.
Yeah.
Sodium nitrate is NO3 again.
Yep.
And it's solid.
No, we don't have to worry about that part. Just extra. Okay.
We do cross like that again.
So what am I going to do now? Okay, I'll take a deep breath. Okay, so now what do we do?
Oh, let me look at here again then.
Now this is a team effort, right? Andy, I know Andy's a genius, but you guys can help him out.
No, I'm not. I just
grams per
I just
mole.
get
So we need to change to grams per mole. How do we do that?
Andy said no, he has it.
I need help. That's why
Oh, okay.
I need Ross help
I
me.
heard something about sodium. Go ahead, Jessica. The guys are just trying to be greedy. So you can go ahead, tell them. Tell them what we need to do. Say
Yeah,
grams per
Judy.
mole. It was Jessica.
Go, Jessica, go. Go, Jessica.
Not just Jessica. Team Jessica.
What?
So I heard something about sodium. So what are we doing with sodium?
We took the atomic mass of sodium,
Okay.
which was
So with that
23,
23.
and then nitrogen, we took 14, and then
And then
oxygen was 48.
That's right. That's why you guys get that 3. That's why. Oh, that's why I never figure out. I know it now. Um, 3, 5,
At 85 grams per mole.
4, 7, 5, 7, 8, 25.
Okay. So what am I going to do with that?
Let me see. 20. Oh, yeah, too small. Oh, okay. 23.
Are you going to put that on the bottom of your next table?
48.
So I put 85 at the bottom?
Yeah.
85 at the bottom, yeah.
Okay. And then grams. That what's on top then?
And
1 mole of
1 mole of sodium nitrate.
Guys are making me so proud. Pretty soon you guys are going to be teaching the class. And I can literally just be sitting here doing my face, you know.
Oh, let
Looks
doctor.
just pretty.
We'll have Judy.
Yeah, Judy.
No, thank you.
Okay, so
And that way stuck.
where you stuck.
So is
Let's
this
get
okay.
unstuck.
1 mole of sodium nitrate on the bottom?
Use your mole ratio.
I need to use
Two.
my mole ratio. So what is the mole ratio? Is it 1?
Two?
It's 2.
Two.
Okay, so it's 2. 2 mole.
Of sodium nitrate.
What's going to be on top?
And we look for the 1. And this one here, the 2A here.
2.
Yeah, this one there. The one by the L.
Okay, you got to realize that I can't see what you're pointing to, right?
Oh, yeah.
Yeah. So 2 moles of what?
Nitrate.
Nitrite?
Yeah, nitrite. NO2. Solid.
Okay. Okay.
And then and we look for the answer here. Let's see. Got 2 times.
So then what do I do now?
We look for the coming together first. And 323.
Is this where you put the
Yeah.
the combination of the atomic mass on top?
The atomic
Yeah.
mass. Okay.
Yeah.
So what will be the atomic mass of nitrate or nitrite?
3. And then 14. Oh, okay. 14. 23 plus 14. And plus 2 of 16. 69. Three, four, five, six.
Okay, so you said what? I'm going to put the mass on top. Is that right, Matt?
Yeah.
And 1 more. Yeah, we get it.
I'm forgetting my
Answer.
N.
And we do the answer now.
Let me make sure I have the chemical equation written down right there.
Chemical equation and 2. How come we never cancel out for the NO2? Okay, 150. And time A. No, divide by A, right? 1.5. 1.2.
What did you get? 122?
Let me go get
1.
Yeah, let me make sure again.
1.22.
Okay, so this is my ideal or my actual? Oops.
Ideal.
Ideal.
Yeah, 1.2.
So if I want to calculate the actual, then what do I need to do?
I don't know. Percent. The gel 895 actual.
So the rule is, the equation is actual.
Percent top. No.
Actual over ideal
Actual deal.
times 100 equal percent
8%.
yield.
Okay. So 95% divided by
Good job.
1.2.
So we have 95%
divided by 1.2 and times 100.
Is it divided by 1.2 or is it multiplied by 1.2?
Multiply.
Multiply. It's not, you put a divide. No.
Hold on, just relax. And you're
95%
anxious there.
divided by 1.2.
Okay, so we got 1.22. Okay, so if we solve for this, we want to solve for actual. So we have actual equals 95 divided by 100 times our 1.22 grams. And what did you guys get?
$1.16.
1.14.
Okay, so that would be my actual. I'm running out of room.
1.22 divided by 100. 1.6. Well, take a picture.
Piece of cake?
No, it takes forever.
No, you guys will be whipping through this in 5-10 minutes. That's all.
Yeah,
Okay.
doctor. Sometimes I take 3 hours for one.
You said sometimes I do what?
3 hours for a question like that.
And sometimes you take 3 hours?
Yeah, usually I'll promise. It was the last night I stayed all night long till 5:30 to do my homework.
That's dedication. See?
Dr. Henry,
Yep.
when you were finding the actual,
Yep.
that wasn't asked for in the question, right? That was just like extra stuff to show us?
No.
No.
It actually, I believe, was because it says, what is the mass of the sodium nitrate that will be produced? Right? So they want the actual what's going to be really produced.
Oh, okay. Okay. I need to pay attention to the questions.
Yeah.
Okay. Thank you.
And sometimes things are inferred, right? That's one case. This is inferring that. It says will be produced, right? Not ideally produced.
Right.
Okay, so limiting reagents. Okay, so how many of you guys like cheese sandwiches?
Grilled cheese.
Grilled cheese sandwiches. Nobody likes grilled cheese sandwiches?
Yeah, I do.
They're okay.
Okay, excellent. Okay, so then this is a perfect example for you guys. Okay, so I'm gonna have a party, and I'm pretty cheap, but I have some really good cheese. I got some welfare cheese. Do you guys know what welfare cheese is?
Mm-hmm.
Okay, so I got some welfare cheese. I love welfare cheese, right? I like to cut my cheese into like big old chunks for my grilled cheese sandwiches, right? And so when I cut my cheese up, I like to cut them in these big old chunks. Get a block of cheese about this big, So I'm going to say at most I will have about 10 blocks of cheese from that block that's about that big. So I have, we'll call them slices. I have 10 slices of cheese. And I have a loaf of bread that is about 25 slices. Come on. Too many eyes. 25 slices of bread. Okay, so what is the recipe for a grilled cheese sandwich?
Two breads and a piece of cheese.
Okay,
I'm so hungry.
2 breads. And 1 piece of cheese. And that's going to yield Okay, do you guys want to argue about that a little bit? Is it balanced?
Yeah, it's balanced.
Okay, you're confident, right?
Yeah.
Okay, good. Okay, so we got a nice balanced equation here, right? So, how many grilled cheese sandwiches can I make?
10.
Okay. Will I have any bread left over?
Yeah.
Yes.
No, but how many pieces of bread do I have?
25. You could.
25. So if I was just looking at the bread only, how many grilled cheese sandwiches could I make?
10.
14.
Oh, yeah.
14?
Yeah.
Oh.
Yeah, because you would have 1 bread left. Or
12 and a half.
or no.
So I can make 12 and a half sandwiches?
Yeah.
Oh my gosh.
Okay. Well, what, okay, no, you guys are right. So 12 and a half. Okay, so I can make 12 and a half sandwiches, right? So if I was just looking at the bread, but if I'm looking at the cheese, how many sandwiches can I make?
10.
10.
10. Okay. So this is an example of limiting. What is limiting here? Which is the one that we're going to run out first?
The cheese?
Cheese.
The cheese, right? So we can only make 10 sandwiches. We can't make 12 sandwiches. Even though we have enough bread to make 12 sandwiches, we only have enough cheese to make 10. So this is an example of limiting reactants or limiting reagents. You'll see both terminology. Okay? You guys see that?
Yeah.
Okay, so who's in excess?
The bread?
The bread.
The bread. That's right. The bread is in excess. And who's limiting?
The cheese.
The cheese. Okay? So you can only use as much cheese as you have, right?
Yeah.
Okay. Simple, right?
Yeah.
Yeah? Okay, good. See, this is all it is. Okay, now I'm going to show you the problem. So this is just showing you exactly the same thing that we were talking about with the cheese sandwiches, right? but we're talking about carbon. Right? We have 3 carbon molecules. So the chemical reaction is 1 carbon plus 1 O2 yields carbon dioxide. Okay? So they come together to form carbon dioxide. So this is our reaction. Okay? So if I have 1 carbon and 1 oxygen gas coming together to form carbon dioxide, how many carbon dioxides can I make?
2.
2.
1.
2. How did you get 1? 1 carbon, 1 oxygen gas come together to make carbon dioxide. So I'll have 2. That's 1, 2. How many carbon won't react? Are going to be left over?
1.
1. Okay? You see the 1 right there. You guys see that?
Yeah.
Okay.
Yeah.
Simple, right? Just like the cheese sandwich. Okay? So the thing is, we're looking at quantity, right? So we got to get things in terms of quantity. Because if we have quantity, we can compare the two. It's going to be based upon our chemical equation. It's a 1-to-1 ratio of carbon to oxygen, right? So we can only use up enough oxygen that we have compared to the carbon. And we have this guy will be left over. So we need to figure out who's going to be in excess and who's going to be limiting. Who's in excess in this case?
The carbon.
Carbon is in excess. And then that means by default, oxygen is limiting. So that means the oxygen is going to determine how much we can make. You guys get that?
Yeah.
Yeah.
Pretty simple, right? Not too hard?
You can give us the hot one, that's fine.
No, I'm not going to give you a hard one.
Calculated mass.
Okay. So it says, calculate the mass of antimony 3 iodide, SbI3, that can be produced by the reaction of 129 grams of antimony and 381 grams of iodine. Okay? So what is the first thing that we're going to want to do?
Identify our given.
Well, we're going to have to identify our given, but not right now. The first thing that we want to do is going to be what? Think about what I did about the cheese sandwiches. What was the first thing that we did?
Find your excess and your limiting.
Well, we can't do that without working with our given, right? But how can you, what was the very first thing that we did? What did we write down first?
Okay, so back to Selena's point, finding out what our given is.
Oh, you just insisted. You're like, finding out what our given is. God damn it, I told you that twice. Aren't you going to listen to what I'm saying? I'm telling you, wait for your given. Wait for that part. What is the first thing that we're going to do? What was the first thing that was written on the thing with the cheese sandwiches? How do we make a cheese sandwich?
Oh, okay, yeah. So you have the 2 breads and a cheese.
I have my 2 breads and a cheese equal a cheese sandwich, right? Or yields a cheese sandwich, right?
Yeah.
So what is that?
Is that a formula or equation?
It is my chemical equation. There we go. So the first thing that I want to do is establish my chemical equation. What is my chemical equation? Says calculate the mass of
SbI3.
Okay, so that's going to be a product or a reactant?
Product?
The
Product. So, okay, so what are my reactants?
129 grams.
Okay, now I don't want the quantity. Am I going to put that in there? Am I going to put 129 grams in there?
No.
Okay, so what am I going to put in there?
SB?
SB.
SB, yeah.
Okay. And
Iodide.
Plus.
so what is the chemical formula for iodide? Since I
Oh, I2.
I2.
okay. Okay. So is it balanced?
No.
Okay, what do we need to do to balance it?
Did you ask someone?
I'm asking anyone who's going to tell me. What do I need to do to balance it?
Put a 2 in front of the SB on the product side, and then I don't know, 3 on the iodine on the reactant side, and then 2 in front of the SB.
Okay. Are you happy?
I think so.
Okay, so we got a balance.
Yeah.
So now we have how many givens here?
The 129, that one.
So we got 2 givens, right? So anytime that you see that there are 2 reactants, 2 given values for reactants, the first thing that should pop in your mind should be what?
Which one's the bigger one?
Which one's the bigger one? Okay. So yeah, in other words, which one is going to be limiting and which one is going to be in excess, right?
Yeah.
Yeah. Okay. So kind of like the cheese. Remember with the cheese? I said I had how many cheeses and then I had how many, right? So I gave you 2 givens, right? Okay. So let's start with the anthony. So we have 129 grams of anthony. Oops. Okay. What do I do now? What am I going to do? I have mass.
Atomic mass of SB? Oh no. Yeah. Right?
Hello? Anyone there?
Would you do the atomic mass of SB?
Yes.
And then
Yes. So what is the atomic mass of SB? Am I going to put it on top or on the bottom?
that's on bottom.
Okay.
That's one, oh, I can't see, 121.8. Gram SB,
And then what's going to be on top?
1 mole SB.
Okay, so then that gives me moles of SB. So I always tell people what you can do. You can't really compare apples to oranges, right? You have to figure out how many apples you have, right? So we want to sit there and figure out how many apples we have. So what do I mean by that?
The mole
So
ratio.
I know, yeah, our mole ratio. We're going to actually use our mole ratio to figure out how many iodine molecules am I going to get with that mass of SB. So what is my mole to mole ratio?
2 moles
Like-
of SB?
SB, right?
Mm-hmm.
2 and 2.
Is it 2 and 2? So SB I'm going to put it at the bottom, right? Or am I going to put it somewhere else?
Bottom.
Okay. Then what's on top?
3
3
iodine mole of
moles of iodine. That's right. So then this gives me the number of moles of iodine that are going to be needed to react with the SB. Okay.
Okay.
So what did you guys get? Do that math for me.
I got 6.35. Oh, never mind. I don't know how you got that. Hold on. Let me check my 129 times 3.
Sorry.
Nope. Oh, I'm putting dividing.
1.5.
Yeah. 1 point. Would it be 1.59? Yeah.
Okay. So this here tells me how many moles of iodine I will need to react with this. So this is going to be what I need. Okay, so now we can use our iodine. And how do I change that into moles?
Listen, we did the top.
Okay. Okay, so you're saying I have 1 mole of iodine on top?
Right.
And what is the mass of iodine?
254. I think.
Just gonna give Judy a hard time here.
Okay, so you want me to put decimals in this. Okay, I'm just gonna remember decimal points.
No, you don't have to. I'm just giving you a hard time. And this is what I have. Okay, so is what I need to react with all of the anthony, is that greater or less than what is that greater or less than what I actually have of iodine?
Less than. Oh.
Less than, right? So that means that this guy here is going to be limiting, right?
Yeah, limited. Oh.
So our iodine is limiting. And then SB is in excess.
That's
Okay, so we've identified what's limiting and what's in excess. So what are we going to use to calculate how much anthony iodide we're making? The limiting or the excess?
The limiting.
The limiting. So we take this guy. I'm going to run out of room, I promise you. So then how do I calculate the number of moles of SB? I mean, of SB iodide, antimony iodide I'm making?
Take the atomic mass.
Am I going to use the atomic mass? I'm just going to start doing what you guys tell me to do.
I'm gonna get it all wrong.
I have moles of iodide. How am I going to relate moles of iodide? Do I use the mass of antimony iodide to sit there and relate that, or do I use something else?
Mole ratio.
Mole ratio.
And where do I get the mole ratio from?
The equation.
From the equation. So remember, when you're in moles and you want to figure out moles of what you're producing or what you're reacting with, you have to use that mole ratio. Don't go to the, you guys are already wanting to go to the finish line. Relax. Okay. So what is the ratio?
3 moles of iodine to 2 moles of SB. Because this is the products, right, that we're looking at now?
Yep.
Okay, yeah. So there's 2 SBs and 3 iodines. Am I
Are we
right?
looking, because we're looking at the product, so do we care about the SB or do we care about the antimony iodide?
Antimony?
Okay, antimony. Is it just antimony by itself that we're worried about?
No.
What are we looking for? Are we looking for this here or are we looking for that? What does the problem say? Calculate the mass of
Antimony iodide.
Okay.
So it'd be 2, it'll be 2 to 3.
Okay. Now, in this case, it didn't make a difference, but in other cases, it will.
Okay.
So you want to make sure that you're looking for the right thing.
Right.
Okay. So this gives me the moles of the antimony iodide. Okay.
Now you would.
Come on, somebody always says it. You always say it, but you always say it a step too early.
That's the
atomic mass.
Okay, we're going to use the atomic mass. So what is the atomic mass of antimony iodide?
121.
SB is what, 122 or 121.8?
Yeah, iodine is 127
And
or
iodide is
126.9
times 3, right?
Yeah.
Okay, what does that equal?
502.5.
Okay.
So it'd be 502.5 over 1 mole.
That is correct. Grams. Okay. Dun, 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 dun. 3 sig figs.
Nathan.
Okay. Okay, and then the last part is also find the mass in grams of the element that will be left. So what is going to be left? So what was limiting?
The iodine.
Iodine. So then what is in excess?
Antimony.
Antimony. Okay, so we have antimony left. We want to figure out how much antimony is left. So do you want to know the easiest way to do this, or do you want to do this the hard way?
No, I want the easiest.
The easiest way to do it is, the law of conservation says what you put in, you must get out. So at the beginning of the day, we're putting in a total mass of these two, 129.
Shut the fuck up. Fucking pager.
Plus 381. You're not supposed to talk to your instructor that way, Judy.
Oh no, I'm so sorry. Not you. Never you. Never you. No, no.
Oh shit, that's how I felt too, Judy. Just kidding. Good thing I'm black screen.
Okay, and then since this is the only product that we're getting out, all we do is subtract that. So what is my answer?
7 grams.
And that would just be of antimony.
And we can always use this.
Yeah, pretty much you can, but if you have multiple products, then you have to calculate how much of the other product is.
Okay.
So that would be the easiest way. The hard way would be, you could take the difference between what you have and what you give, and then use this moles of iodine, convert back to moles of antimony, and then multiply that by the molar mass, and then it'll give you the same answer. So you could just subtract these two. So it'll be 0.09, and then use the molar ratio of iodine to antimony. So that will be the long way, the more complicated way.
So the longer way is, let me just make sure if this is right. The limiting. So the limiting is our iodine.
You would take the one that's in excess.
Oh, excess.
So, moles of iodide minus your limiting.
Mm-hmm.
Which is we gotta move this out of the way. I ran out of room, so. Oops. So this is continued down here. So that's mole of iodide. And then you convert. Let's see, where can I put it? I put it here, up here. Can you guys see it?
Mm-hmm.
So 0.09. So what is the molar ratio between iodide and anthony?
2 to 3.
So we're going to use this as a line here. So it's 3.
3 moles iodide. And then 2 moles SBI.
No, just SB.
Oh, just SB.
Because we're just talking about anthony.
Right.
That's hard.
Okay. Then we go 1 mole of anthony.
And that's when you put the grams on top?
Yep.
Okay.
And that's going to equal should equal 7. We'll see.
7.311, so 7.
Okay.
Interessante, yes.
So you learn the easy way and you learn the hard way.
Thank you for showing us.
No problem.
Are we done for
I love these problems. These are realistic. So how many times have you been cooking something and then you run out of something? You're like, oh, I don't have enough for this.
All the time.
All the time. So realistic. Okay, questions, concerns, Cash? Everybody got it down?
Yes.
Can I erase? What was that? I can erase.
I said I need practice on this, but
Yeah, it takes some getting used to. Even though it's very logical, right? Very logical. But for some reason, when you guys start seeing chemicals and stuff, you throw logic all out the window, right? Because you know it was real easy with the grilled cheese sandwiches, right?
Mm-hmm.
So this is exactly what you're doing with the grilled cheese sandwich, right? Exactly. Only thing instead of starting with quantity, in the case of the grilled cheese sandwiches, we weight the cheese and we weight the bread, right? Rather than counting the slices.
Yeah.
Okay, so I think this is a good stopping point.